Hello and welcome. I'm going to be answering WAEC 2020 Chemistry Objective Part Question 20. The following molecules have double covalent bonds between two atoms except A. Oxygen, B. Carbon 4 oxide, C. Ethene, D. Water. So we're looking at covalent bonds, and of course covalent bonds are formed by sharing of electrons. In other words, there is no transfer of electrons, unlike in electrovalent or ionic bonding. So you have some molecules here that possess covalent bonds, but we're asked which of them have double covalent bonds, or double bond, which is usually represented this way. So double bond between two atoms. So let's look at each of the options. Now, oxygen, an oxygen molecule, of course, is O2, that is made up of two atoms of oxygen. Now, each atom of oxygen has 6 valence electrons. 6 valence electrons. So you have one like this with 1, 2, 3, 4, 5, 6. So you have 6 valence electrons, and then you have another with 6 as well. So 1, 2, 3, 4, 5, 6. So when they combine, they form something like this. They form something of this nature. So you have something like this. Now, they each need 2 electrons to complete the stable state, the stable octet state. So they share 2 electrons. So it looks something like this. You have this one, 1, 2, 3, 4. So the last 6, 1, 2, shares the last 2 with this one, and this one also shares 2, 1, 2 with this. So 1, 2, 3, 4. So what you have here is a double bond. You have double bond because this particular one is sharing 2 electrons with this, and this also is sharing 2 electrons with this other atom. So you have double bond. So this possesses double bond and cannot be the answer to this question, because we are asked which does not possess double bond. Now, option B, which is carbon 4 oxide, is something like this. So that is, you have one carbon atom combining with 2 oxygen atoms. So of course each oxygen atom will have 6 valence electrons, and the carbon atom has 4 valence electrons. So the structure that will be formed looks something like this. You have one of the oxygen this way with 6. So 1, 2, 3, 4, 5, 6. Now that 6 is going to be shared with the carbon atom. The last 2 rather will be shared with the carbon atom. So 2 of those carbon atoms out of the 4, 1, 2 out of the 4 valence electrons of carbon will be shared with one of the oxygen atoms. And similarly on the other side, where you also have another oxygen atom with 6 valence electrons, that is 1, 2, 3, 4, 5, 6. So the remaining 2, remember the carbon has shared 2 of its valence electrons with this oxygen atom. It will share the remaining 2 with these other oxygen atoms. So that's where these 2 double bonds arise. You have 2 double bonds. You have one here and another double bond here. So this possesses double bonds and is not the answer to the question. Now option C, which is ethene, has a structure like this, a rather complex structure like this. This is an ethene molecule, you have a complex structure like this, and looking at this structure, you see that the double bond lies between the carbon atoms, the two carbon atoms you have. So the two carbon atoms each have 4 valence electrons, so it shares 2 of those valence electrons. This one shares 2 of its valence electrons with this one, so you have the double bond. Then the remaining 2 undergoes other forms of combination with the hydrogen atoms surrounding it. And then lastly, so like we have rightly said, a thing has double bond as we have seen here, and hence is not the answer to this question. However, for a water molecule, what you just have is one hydrogen molecule. We have hydrogen molecule, 2 hydrogen molecules, each with 1 valence electron. And what they do is they share each of these valence electrons with 1 oxygen molecule, with an oxygen molecule. So with that, the oxygen molecule of course contains 6 valence electrons and requires 2 to complete it. So each of the electrons required is gotten from the 2 hydrogen atoms. So you have 2 added to the 6, 1, 2, 3, 4, 5, 6 to form a covalent bond. And as you can rightly see in the water molecule, there is no double bond. So the correct answer is D, water. Water does not have double covalent bonds. Thank you, and please subscribe to our YouTube channel for more videos and for more past questions and answers.